2030 will pass, 2050 will pass. There will be no climate catastrophe.
For years, world leaders have used 𝐑𝐢𝐜𝐜 to warn us of an impending climate catastrophe.
We are on a highway to climate hell with our foot still on the accelerator.
We are told that burning fossil fuels and emitting CO2 are making our planet uninhabitable.
Creating the droughts and melting the ice and raising the sea level.
Europe in particular stands out for its eagerness to pursue an exceptionally costly climate policy filled with restrictions.
The world stands at a critical juncture in the climate crisis.
Climate change is still on top of the global agenda.
Although we are told there is scientific consensus behind the declaration of a human-caused climate crisis, thousands of scientists disagree. I'm in Paris to meet Dr. Richard Lindzen. Dr. Lindzen is an atmospheric physicist and emeritus professor of the prestigious Massachusetts Institute of Technology. Lindzen has studied climate throughout his long research career. He says that human impacts on climate are clearly exaggerated and there is no basis for climate alarm.
When somebody says it changes 1/10 of a degree, or when Gutierrez says if it changes 1/2 degree, we're finished as a species. This is an existential threat. People have to ask, what the hell are they talking about?
In the following interview, Dr. Lindzen breaks down climate issues, discusses the nature of climate change, and refutes some of the half-truths and outright falsehoods spread by climate alarmists. Dr. Lindzen, let me start with a quote. The fact that the developed world went into hysterics over changes in global mean temperature anomaly of a few tenths of a degree will astound future generations. Well, you are of course familiar with the quote because it's yours, and this is from an essay that you wrote in 2009. Well, it's now 2025, and for me,
I would have said much the same in 1990.
Really?
Yeah.
How come?
Yeah, it's a fair question. Where did this come from? And to be honest, I don't entirely know. Some of it began, I would say, already in 1970. In 1970 already, the environmental movement changed to an emphasis on energy. Well, you're too young to remember, but the first thing they were concerned with was, of course, global cooling. Forgive me if I use this term because I think it's a very bad term. When they speak of the Earth's temperature, I have no idea what it means. I mean, I don't know how you take the temperature of the Earth. Are you going to average Mount Everest with the Dead Sea?
I don't know, but let me tell you, I'm confused because they are telling us that
the world is warming.
The world is warming and the temperature rises.
What are they talking about? Do you have any idea?
I guess average temperature?
No, we can't average the Red Sea, Dead Sea, with Mount Everest. What are they averaging?
So what are they talking about?
Okay. The formal definition these days is they are taking at each station a 30-year average, looking at the deviation from the 30-year average at that station, and that's what they're averaging. It's the average change over the globe.
Hasn't NASA told us that?
Then they have the satellites. They are doing something else, because they are measuring a thick layer of the lowest 10 kilometers or 5 kilometers, and so they are averaging a temperature. Because they don't have a mountain, they don't have a valley, it's just air. How do you compare them? I don't know. Because people are throwing around numbers. You suddenly have a public, they're listening and they say, the temperature was up 1/10 of a degree this year, and that's a record-breaking year. And you say, I can't tell 1/10 of a degree. If I take my temperature, the doctor doesn't care if it's 96.7 or 96.6. What are they talking about? But we're somehow assuming a tenth of a degree matters.
And it doesn't.
Does it matter to you?
I don't know.
If the temperature changes a tenth of a degree now, you can say, oh!
Well, we're doing this interview in Paris, and today in Paris it's quite a warm day.
Yeah, sure.
Yeah, but
It's
in the
quite
morning
warm.
it was
That's
something
because it's
like
20 degrees warmer than it was, or 10 degrees centigrade.
Yeah, exactly. Because in the morning it was under 20, and currently it's almost 30.
Yeah, and we survived.
I must say, we are here.
Yes. So when somebody says it changed a tenth of a degree, or when Gutierrez says if it changes a half degree, we're finished as a species. This is an existential threat. People have to ask, what the hell are they talking about? I have my thoughts as to why it is that educated people don't ask questions. For most of my career, I've been a teacher. And you have some students who are really very good, but most are okay. They're not great. They're going to have jobs, they're going to do them reasonably well and so on. But for them, succeeding in school is mostly pleasing the professor. So no matter how stupid the professor might be, they've learned to rationalize what the professor said. And so the skill that most people pick up at the university, I suspect, is the ability to rationalize any statement, no matter how ridiculous. So if somebody says a half degree is the end of the world, I can see that. The ordinary person does not have that skill. He knows a half degree is small. That's, you know. You saw this with the farmers here, the truck drivers in Canada. None of them believe this stuff.
What do you think about the academic quality nowadays in the US and well, in the Western societies in Europe?
I mean, we're watching our universities self-destruct. It's outrageous. I mean, if you looked at Harvard University, I mean, I graduated from Harvard. I taught there. I was a professor for a dozen years. That they had a president, Claudine Gay, who wrote 11 papers in her whole life, and most of them were copied from something else. How did this happen? At MIT, we have a president, Sally Kornbluth. I'm sure she's a nice lady. She was a biologist at Duke University. She hasn't the faintest idea what she's doing. She needs to say she has some grand idea, so she's decided the grand idea is climate. She knows nothing about climate. What is the big problem she's dealing with? How to get the music department involved in the war on climate. I mean, it's absolutely crazy. Meanwhile, you know, if you're a young scientist or a working scientist, I'm retired, but if you're working today, you cannot get funding if you don't agree with climate alarm. You cannot publish if you don't agree with climate alarm. It's completely taken over. And I see this at MIT. I still have colleagues who are professors who are still teaching. And they are coming to me and saying, you know, I don't know what to do. I don't argue that there can't be warming, but this is not an existential threat. Steve Koonin writes a book. He is looking at the UN reports. In the reports, you have many different sections. Only one deals with science. That scientific report never says that it's a big deal. It simply says, we're more likely to warm than to cool, and it'll be a few degrees, maybe. But nobody in those scientific reports is saying there's going to be extreme weather, or that it's going to be flooding, or the world is going to end. Now that's politicians. And the politicians have arranged the UN reports so that you do have one section on science, and then you have lots of other sections that are not on science that say crazy things. And so you say the UN says this, but it doesn't say it in the science section. They designed it so that they would have a platform for issuing crazy statements, but there would be one section that is the science that no one would read, but allows them to say they had hundreds of scientists working on this.
Some decades ago, you were one of the lead authors.
Yeah, I was working with the IPCC, and you know, it was absurd. In order to write 3 or 4 pages with 2 other people, we traveled around the earth 2-3 times. You know, there was a meeting in New Zealand, a meeting in Nairobi, a reading, and you know, the 3 of us, there was a fellow called Pierre Humbert, who's today at Oxford. There was another guy from France. And we all decided, look, we may not agree, but let's not say anything that we know is false. And so the section was on what we knew about feedbacks. And it was a completely honest section. It was biased. We were told we couldn't attack models too much. But basically what we wrote was honest. It said we didn't know what we were doing.
So models, computer models.
Models are their own story. Models are useful, but not for prediction. The reason they're not good for prediction is we don't know the feedbacks, we don't know this, we don't know that, we don't know clouds, we don't resolve this. So they cannot handle processes that are essential. They're useful if you're doing theory. You can look at the models and see how things interacted, and then focus on those more carefully to see whether you understand the interaction. So there is a kind of back and forth between models and theory and so on, but that isn't how they're used. The issue began with no science at all. It began, as I said, with global cooling. As long as there was some way this number, this crazy number, was showing cooling since from about 1939 to 1973, they said, well, let's say it's cooling. And you then had models, they were called the Boudico-Sellers models. All of us liked to play with them, they were cute. They showed if you reflected light with sulfates enough, the original version of the model would give you an ice-covered Earth. That seemed very dramatic. And then people, including us, began showing, well, if you put in something more realistic in the tropics, it stopped there at 30 degrees. And then finally, in my course notes, I have a problem where you put into this model the change of seasons, and the model falls apart completely. So for the global cooling, you had the model you needed to give a scare story for cooling. But then in '73, in the 70s, it stopped cooling. So you needed something else. What was the next thing that came up? It was, again, the energy sector. Acid rain. The forest in Germany was dying. Unfortunately, after a few years, the forest stopped dying. And so acid rain was not too useful. People tested it. They found it didn't have much impact. But then they noticed the temperature was increasing, and that they liked. Why did they like it? Because the reason you would give for the temperature increasing is CO2 was increasing. Why did you like CO2? Well, with global cooling, You were worried about sulfate aerosols. The trouble with sulfate aerosols is we know how to clean them. We can build a coal plant that has no sulfate emissions. Well, what good is that? CO2, nothing can stop that. It is the product of any burning, including breathing. So you generate a lot of CO2. Anything that burns a fossil fuel produces CO2. After you clean every real pollutant out, you still have CO2. So this was guaranteed to get rid of any fossil fuel. And that was its attraction. And that's what we've gone with for the last, since '88. And it was interesting. You know, you were a little surprised when I said it began many years ago. In 1988, you had a Senate hearing in the US, and you had a man called James Hansen testifying. It was an interesting issue. It had been going on for some years already, but he came there and said that increasing CO2 was going to cause a lot of warming. And Newsweek, it had a cover showing the Earth on fire, and it had a label, "All scientists agree." And that was very interesting, because at that time, almost no scientists were working on this. People were told all scientists agree. Now, think of that from a propaganda point of view. You don't know science, you haven't studied it, most people haven't studied it. Even among the people who studied the science, for this problem, a big part of the problem is fluid mechanics. Almost no physicist ever studies fluid mechanics. So, you know, you have something that hardly anyone has studied, and so you're saying, what am I going to do? I don't understand this. You are told all scientists agree. This is a source of comfort. You don't have to understand it. All scientists agree. You can agree too.
Actually, we hear it more and more nowadays that there is
now you have more and more scientists.
97% consensus.
Oh, that's fake. You know, how should I put it? That always depends on the question. So, for instance, if you asked the question, is doubling CO2 more likely to warm than to cool the Earth? I would think you'd get 100% agreement. But that's not the same as saying it's a serious problem. So at that level, if you ask the right question and put a funny interpretation on the answer, you can say all scientists agree. You just haven't said what they agree with. Then you have the paper by Cook that said 97%. They looked at journals and tried to find articles that discussed certain impacts of climate. And so they looked at, don't take my numbers seriously, they looked at 1,000 articles. They found 40 articles that spoke about certain impacts. And for those 40 articles, they found 97% said, and so they said 97% said that, but it was like a few percent of the total.
What is your opinion on this phrase itself, consensus, scientific consensus? Is it something that science is made of? Is it made of consensus?
No, of course not. I mean, it's whenever you hear consensus science, you know something is wrong. So, for instance, you know, this was in the Soviet Union with Lysenko. Yes, there was a consensus in favor of his view of evolution, because if you disagreed, you went to the Gulag. I mean, it's a powerful argument. I mean, it's, you know, today it's equally true if you're teaching and you're not part of the consensus, you don't get paid. It's better than the gulag, but I mean, it's...
What is the state of climate science and climate teaching in the university?
Oh, it's horrible in the sense that, first of all, there is so much money thrown at climate. As I mentioned to you, when the issue began in public in '88, it began earlier, you had very few departments and very few people working on climate. All of a sudden, when the government is providing money, when the UN and all the European EU are providing money, all of a sudden every university now has a climate group. It doesn't advance the subject because no one is permitted to actually study it. If you actually studied it, you would see this makes no sense. We actually wrote a paper about a year ago trying to address the question, why do you argue that a degree, 1 degree, is important? And if you pressure people who are working on it, they will say something like there is polar amplification, that whatever you do in the tropics is amplified at the poles. Now, for people who worked on the theory, you know this isn't true. What determines the temperature difference between the tropics and the pole is the fluid mechanics that produces the high and low pressure areas that you see on your weather map. And they carry heat to the pole, and they determine the temperature difference. It's not an amplification of the tropics. But you can at least ask the question, does the data show that it is? And what we were able to show is that in the data from about the early 19th century to the present, there's no polar amplification. So all that you're getting is that half degree, that 1 degree. 1 degree every place is all the contribution from greenhouse. And, you know, for practical purposes, this is much smaller than the actual climate change that has occurred. The Gulf Coast of the US has gotten much colder. That is a change, but it doesn't reflect itself in the equator to pole, tropics to pole. It's local. And in fact, most of the climate change associated with time scales from about 3 or 4 years for El Nino to 1,000 years, let's say the medieval warm period, are probably due to the ocean. You know, you have the ocean is much denser than the atmosphere, obviously, and as a result, its circulations take much longer. They involve much more mass. And so ocean circulations, depending on their depth and so on, you know, with El Nino, it's 2-3 years, few years, they up to 1,000 years. And what happens? You have circulations that are taking heat away from the surface and bringing heat to the surface. So the surface is never in equilibrium with space, which is the basis of a lot of the simple discussions. It's always changing the surface, but it changes it locally. So different ocean currents are peculiar to different regions of the ocean. We know that the Earth has many different climates already. The climate in the Sahara is different from the Mediterranean coast, is different from Scandinavia, is different from the Baltic, and so on. But if you look at each region, let's say Tallinn and London, or Tallinn and New York, the changes don't correlate. They're each different. And so you have a world where climate change is occurring always, And on time scales that we're looking at, like the medieval warm period, the Little Ice Age, and so on, it'll be very hard to understand because it'll involve all the details of the ocean interacting with the air. You then have the big changes, the last glacial maximum when, you know, half of North America is covered in 2 kilometers of ice, and you have the Fennoscandian ice, and so on. You also have 50 million years ago, the Eocene, when you had alligators, or like alligators, in Spitsbergen. Those involved the changes in temperature from the tropics to the pole. That depends on fluid mechanics, it's internal, and it depends on surface conditions. By that I mean, you know, if you have ice or snow on the surface, it changes the response at the surface to the waves, the highs and the lows. It's somewhat complicated, but people have worked it out. There are papers that have done this. They're very hard to follow. This has been true for a long time. Do you know the name Werner Heisenberg?
A physicist.
A physicist.
Yes.
And he's associated with the uncertainty principle.
Yes.
But, you know, his doctoral thesis was on fluid mechanics. And he made the point that fluid mechanics is hard. And we still have no understanding of turbulence and all these things. But it's a crucial part. When you look at a weather map and you see the highs and lows, this is a form of turbulence. It's just that, you know, when you're looking at it in a boiling pot, the eddies are small. When you look at it on the scale of the Earth, they're the size of countries. But they're still turbulent eddies. We know that they are separate from the greenhouse. So in terms of our knowledge of the system, it's not zero, and we know it doesn't fit the picture that is being talked about. But you asked, you know, how many people work in it and so on. Well, by now, when the government gives out money, hundreds of universities all have climate issues, but they haven't got the people to train people in the physics. So they all sort of agree, and you have things like I mentioned at MIT, where the president of MIT worries about how to get the music department to fight climate.
Humans have some impact on climate, or what is your opinion on that?
At some level, the cities have a different climate from the countryside. So that's a human impact. It's called the urban heat island. A broader impact on climate? I doubt it.
But why is it that this global warming debate is so concentrated then on CO2?
Because it's not a debate. And it began essentially in the 70s. You had work arguing how you could make CO2 bigger, a bigger effect, the so-called feedbacks. One of the bizarre things today, there was a man called Manabe. He wrote a paper in 1973, and he argued that if you modeled the atmosphere with a one-dimensional model, remember, we have 3 dimensions in time. He got rid of time, he got rid of 2 of the dimensions, just vertical, and he said, if I assume that as the atmosphere warms from increasing CO2, and doubling CO2 gives you a ½ degree, so it's not much. He says, if you assume that at the same time the relative humidity stays constant, so that when you warm you have more water vapor, that will double the impact of doubling CO2. And that was a revelation, a false revelation, but a revelation, because until then there was something called Chatelier's principle. Chatelier's principle was never proven, but it was an argument that nature tries to prevent change. Manabe has come up with something now that says, if his assumption is correct, nature can amplify what man does, which sounds like something very strange for nature to do, but it became the heart of all the models. They all now try to arrange things so clouds and water and everything amplified whatever man did. And Manabe got a Nobel Prize in physics for this. Even though it's never been confirmed, it doesn't seem to be true, but it allowed you to make models that were more sensitive, because CO2 does almost nothing by itself. When you have very little CO2, each molecule is pretty effective. But, you know, we have so much CO2 in the atmosphere, even though it sounds like not much, that it already blocks infrared. It's like if you have, you know, I've said this for about 50 years, if you take your window and paint it black, okay, it'll keep out a lot of light. You now add a second coat of black. Does it keep out as much light? No, there's no light coming through, so it does less and less. That's what happens with CO2. We have so much already that when you add a molecule, it doesn't do much. The way this shows up, and this has been known since a man called Arrhenius, a Swede around 1900. The way it shows up is you get the same effect of CO2 every time you double CO2. So for instance, if you start out at 280 parts per million and you go to 560, doubling it, you get about a half degree. Now to get another half degree, you have to double 560 to 1120 to get the same half degree. So now you needed, instead of 280, you needed 500 some odd. And then to get another half degree, you'd have to add 1,000. So, you know, it's saying each molecule does less than its previous one. And that's been known, as I say, for more than a century.
There are those big projects now built with taxpayer funds that those big fans, you know, that suck carbon dioxide out of the air, and I understand this carbon dioxide is moved to Iceland, and then there's a factory there and it makes rocks out of carbon dioxide. You're laughing. What do you think of such projects? Billions are...
Yeah, no. It will cost a fortune. It cannot handle the change very well. No, you know, how should I put it? Do you know the name Hayek, von Hayek?
Yeah, of course.
Okay. He actually...
Liberal economist.
Yeah, he disliked engineers. And at MIT, I can understand a little bit why. Engineers love to solve problems, even if the problem doesn't exist. And so you tell an engineer CO2 is a problem. He goes to work. How do I get rid of CO2? And, you know, if he's entrepreneurial, he'll start a company to get rid of CO2. So, you know, they're, in a way, an uncontrollable function that will respond to anything you call a problem. But, you know, think about it with CO2. Let me ask a simple question, because I don't think people even understand. I mean, what happens if I get rid of about 60, 65% of the CO2 in the atmosphere? Do you have any idea?
No, I don't. I have a suspicion. I suspect that it is not going to be very good for nature. But
Forget for nature. How about us?
Exactly, because we're part of
We'll
nature.
die. We'll die of starvation.
Put simply, yes.
At 160 parts per million, virtually no plant will survive. No plant survives, there's no food.
So CO2 is very important, but it's demonized irrationally, and really, I'm puzzled. I cannot get it to my head. Why is that done?
I think for the same reason, years ago, as a joke, someone asked people, is it a good idea to get rid of H2O? And they said, yes. It's a chemical. We get rid of chemicals. I mean,
some people still use the world climate crisis to describe today, or at least that we are heading towards the climate crisis.
What is a climate crisis?
Exactly, that's what I wanted to ask. Yeah.
I mean, they often give you a picture of New York underwater.
It would be a crisis.
It would be a crisis if it were true. But even if it were true, how shall I put it? We're talking about thousands of years. 1,000 years ago, what was in New York? Nothing. You had the geography, there were some Native Americans living there, but nothing special. 1,000 years from now, who knows? But it's perfectly clear that if the coast of the US were 40 miles inland from today, the US would still be a viable country. And instead of New York, you would have Philadelphia or Chicago. So, I don't know how to talk about 1,000 years from now. And nobody 300 years ago knew how to talk about today.
There is a lot of talk about those tipping points. So they are saying that if temperature rises, small changes will be consequences.
It's a statement that if you go beyond a certain limit, you then leap. This is a property mostly of systems that have what are called very few degrees of freedom. So when you have a system that has very few possibilities, then if you push it too hard, it has to jump to something. This is not a property of a continuous system like the climate. The climate does not go through tipping points. This is an artifact that people who want to generate a scare story throw out. And if you're not a scientist, say, gee, what is this tipping point? But it's not for a system that is continuous. It's for a system that has no choice. Our system has lots of choices.
You mentioned those extreme weather events. This is a claim that is being made.
Absolutely,
the crisis is linked
to
extreme weather events.
I think there's no better evidence that this is a fake issue. Issue after issue of these Intergovernmental Panel on Climate Change reports, they always looked, is there any relation between extreme weather and their metric for climate? And they always find there is no statistically significant relation. In the meantime, you have the people who are pushing climate change and CO2 reduction, and they're going out of their minds. How can they convince people to get worried? And so they're showing this temperature graph. And I think they're realizing, people are saying, you draw it like this, but this is 1 degree. That's not much. And they're worried. This is not getting people worried enough. So they're saying, well, showing them a flood, showing them a storm, that is visually convincing. You could get 5 or 6 pictures each month of some place on the earth where something dramatic has happened. And you can say this is a 1 in 100-year event. And people don't figure out a 1 in 100-year event someplace on earth is occurring every month, or 5 places every month. You have a picture of that. You now put that on television, and you can associate, quote, climate change with something dramatic, and people see something dramatic, and so this helps them to visualize some terrible future. The fact that they had to go to that to convince people suggests it was a fake issue, because they're clearly using something that would be called normally false advertising.
What people often are told is that if we don't do anything, well, if we link it to climate, then there will be climate change and there will be climate refugees and it's going to be worse. And
they're told that.
yes.
And they never ask, how come? What is it about a 0.5 degree that is going to cause people to migrate that are not migrating already?
Exactly, because they're migrating for economic reasons.
The public never does arithmetic. They hear, you know, if Western Europe, or if Europe and the US and Australia and New Zealand all stop producing CO2, it won't do much. First of all, because China and India are continuing, but it really wouldn't do much anyway. So what are people told? Everyone must do their part. And so you have people willing to do something even though they know it will have no impact.
That's what I'm trying to say. They don't know. They think
maybe they're doing something, but they are told often that, you know, it's true that if the US does it alone, it won't have much impact because it's global, but everyone must do their part.
yes, this is something that has been told. Even tiny Estonia should do our part, even though we don't matter much.
Exactly. I mean, it's appealing in a way to people's good nature or wishing to do something important and getting them to commit suicide. I mean, you look at Germany today, they're losing their industry. BMW is made in Hungary, as far as I can tell. I mean, it's just, their unemployment is increasing.
Well, let's talk about those energy policies as well, those climate policies that are currently still moving in Europe, for example, the move towards net zero. At what cost will it be achievable? Is it even achievable?
It's a wonderful example of the breakdown of what people call cost benefit. Will Happer and I have a little note pointing out that if you reach net zero by 2050, if you do it worldwide, you avoid about 1/3 of a degree. If it's just Europe and the Anglosphere, it's closer to 1/10 of a degree. So you have avoided 1/10 of a degree of warming at a cost probably of tens of trillions of dollars. Doesn't seem like a bargain to me, but I mean, as I say, the trouble with it is the political calculation. If a politician in America can give away trillions of dollars, he can get back enough to run for office for the rest of his life. Politicians do not get a high pay, and yet they end up with the biggest mansions, expensive cars, and so on. Yeah, it's a question that people occasionally wonder about. But climate is a good vehicle for this, and because the energy sector is so big.
What do you think about reducing fossil fuels? Should we do it still?
Until the end of the 18th century, human existence was relatively static. population didn't change much, standard of living didn't change much, and all of a sudden, at the end of the 18th century, you began this astounding increase where the population is increasing, the wealth is increasing, the income is increasing, life expectancy is increasing. I mean, it makes you wonder when you just correlate things and call it causality. Is it that life expectancy is increasing that's causing warming? Or, it just gets crazy. But what happened? What caused that? The steam engine. All of a sudden, mankind was able to exercise more energy than he himself could produce by designing engines. And ever since then, we've gotten better and better at that. And that has led to the greatest increase in human welfare in history. And we're now feeling guilty about it. I mean,
yes, we do.
Yeah.
We do. We want to stop it, to be exact.
no, we want to stop it for the people who are still poor.
Yes, as I understand, policies are in place not to allow, for example, Africa to develop because of climate.
Right.
Because of climate,
it's their obligation to us. No, of course.
Well, morally, it is kind of repulsive, even.
How shall I put it? Fortunately, they don't agree. The only reason I could see for reducing fossil fuels is a concern that we're running out. And then you might want to limit your usage. But that seems to me also a little bit naive, because at present, fossil fuels are the basis, to a large extent, of societal prosperity. It will only be prosperous societies, I think, that will afford the research to look into other things. Obviously, nuclear has a role, and with the modular systems, it'll overcome one of the problems with nuclear, which is starting it up and down and changing it by small amounts to adjust to the load. So nuclear has the potential for providing energy for a long, long time by historical standards. And then there's fusion, and that always seems to be in the distant future. But, in a few hundred years, I think we'll probably have a good idea of how to do controlled fusion. So I don't worry too much. I mean, at the moment, the supplies of fossil fuel are increasing. So when you had fracking, all of a sudden you had access to much more fossil fuel. There will be improvements like that. We really don't know how much there is. So far, we have generally underestimated how much there is. So between, those factors, new methods of extraction, fission, nuclear, fusion, I think, one can expect a future in which energy is in stable relation to population. We have bigger problems potentially coming up. I mean, I find it ironic that we're suddenly waking up to the fact that we don't have enough people. I think your generation is finally waking up that if population keeps going down, nobody will pay for your retirement.
That's exactly the problem. There's the demographic collapse all over.
Yeah, no, and it's happening even in Africa. There are all sorts of problems that are coming up that we're not thinking about while we think about problems that are not coming up.
What you're saying is that we're too focused on something that is not a problem,
Yeah.
And we should be focused on real problems.
Well, yeah, that's first of all. And, you know, never to take yourself so seriously that you have to invent problems.
What advice would you give to our Estonian politicians? Well, of course, we have plans to go to net zero, and we have plans that in 2030 we produce annually as much energy from renewables as we consume, so 100% or even 120%. So does it even sound logical to you?
How shall I put it? First thing I have to say, I think Trump is doing the correct thing. He is ignoring all the climate issues and saying, drill, baby, drill. So the US is big enough when it decides to ignore the whole thing. I think the rest of the world has to think twice, because by now, if the US is ignoring it, China is ignoring it, India is ignoring it, Southeast Asia is ignoring it, and Russia is ignoring it, why commit suicide? I mean, there may be guilt, there may be all sorts of things, but you don't need an energy policy, you need a psychiatrist. So that's the first. I mean, you know, with 2030 and net zero, this is posturing. It's impossible, and it'll do nothing. So this is a kind of, how shall I put it, a funny sort of dance that people are doing. And I don't understand it, but it's caught on, it can't go, can't work, won't happen. And as far as renewables go, nothing you say makes them less intermittent. They, you know, if you say you've done 110% with renewables, what happens when the wind doesn't blow, when the sun doesn't shine? What happened to your 100%? It's gone. And the trouble is, and this has been one of the obvious things, why are renewables so expensive? I mean, people are thinking, you know, we don't have to pay for sunlight. How come my electricity bill goes up so much? Well, first of all, among other things, they don't work all the time. And if you have to take your fossil fuels, your natural gas or your coal, and turn it on and turn it off and turn it on and turn it off, your efficiency goes way down. And so in addition to using the, quote, renewables, you are also being forced to use the traditional sources in the most inefficient way possible. This makes no sense. The EU and European countries in general are behaving very strangely. I don't know how they will respond to what Trump is doing. But what he's doing is making it obvious what Europe is doing will be of no help to the climate and will hurt Europe. How far will the population go in saying, we will sacrifice ourselves for a symbolic gesture? I don't know. I mean, this is again a statement of peculiar behavior.
What advice would you give how to come out of this thing as a politician?
Yeah, the easiest way is what Trump is doing. I mean, again, different countries, the EU is such a complex system. I don't understand how the European Commission can have the power it has. You know, and you know the way they refer to it, the democratic deficit. That suddenly you give power to a group who you never elect. I think it's a bad idea. I hope it changes eventually. I think you can have an organization that, you know, has a passive role to investigate things, but you can't have a bureaucratic body that has powers that replace democracy. So, you know, it's tied up to many things. I think if individual countries have a choice, they'll each decide probably to drop the climate issue. And to be honest, 50 years will pass, there will be no climate catastrophe. 2030 will pass, 2050 will pass. Just like 2000, you know, Gore predicted New York underwater by 2000. We should notice it's still above water. You know, all these predictions always fail. At some point you have to say, if all the predictions fail, maybe your ideas are wrong. I mean, it's... So, you know, I think I'm optimistic that there does come a point when people say that. And it will be interesting to see if in Europe, individual countries understand this and the European Commission does not. What will happen? I would suppose they would have to decide that the European Commission is useless. So there's a more optimistic future.
Yeah.
Join the fight to defend our freedoms. Follow Freedom Research on Substack